So this is ours and Richard, you are connecting CS1042. So this is our experiment 2. That is, we have to do postfix expression evaluation. Okay. So what is our aim? Our aim is to evaluate the postfix expression with the help of stack data structures. What are postfix expression? First, we'll understand three basic expression type. What is infix? Infix expression Abbreviations are those in which we write operator in between the operands. What is prefix? Where we write operator before the operands. Postfix. These are all Polish notation. Postfix is where we write operator after the operands. Here we don't have to care about precedence or parentheses, and postfix expression is also known as reverse Polish notation. Here we don't have to care about operands since when we convert it to postfix, it automatically gets arranged with the help of precedence. So our main aim is to take a string. Just we will see example what we are gonna do. We will take a string 74 minus 3 into this is our postfix expression. So we are going to push one by one in the stack data structure. As we encounter a number, we push in the stack data structure, and whenever we encounter a operator, we po- we take the top, then second top, then we multiply, then again push back it to the stack data structure. We continue until our end is reached. So we can see here how we got 4 and minus 3, we multiplied and pushed minus 12 into our data structure, and in stack data structure then again we encountered 1 and 5, then we encountered plus, then we add 5 and 1, and then again push it back to the 6, then we got divide 12, then we divide minus 12 by 6, we get minus 2, then finally we get multiplication operator, then we multiply and output the final answer, that is minus 14. So we will see how our code works. In this is the boilerplate code, which includes all the header files. We don't have to define stack separately. Everything is defined in this boilerplate code. Here we define string s. Here we define string s. We take the input from the user, and here we define stack. This is a stack from the STL library which is inbuilt. We have to define stack, and here as we define stack, st.pop st.push all the functions are inbuilt. So we don't have to make an array and define all the functions from start. And since stack is dynamic, you can push. In array, what happens is we define a certain size. So and we move the pointer ahead when we perform pop operations, so that will cause memory leakage. So in this STL we have stack inbuilt, so we don't have to worry about the size and the memory leakage and all. Now what we do is we assign t to array size, then we will traverse through this whole string, and whenever if we encounter a plus, okay, so whenever we encounter a plus, what we are gonna do, so basically when what we will input is, so what we're gonna do is first assume that first element is 5, the next element we push is 4. So here we have pushed 5 and 4. So whenever the suppose whenever we encounter a 5, here we are pushing in a stack st of push minus 5. So since s of I will be a character, so we are defining array of integer type. So C++ knows that we have defined array of integer type, so it will convert character to its corresponding ASCII value. And since zero's ASCII value is 48, we will subtract our character minus 48 so that we get our original number. So here we will get the ASCII value of 5, then we will subtract it from 48 so that we will get a 5 in our stack. So then the next, if we assume if we encounter plus, so here it will come in this condition statement if we encounter plus. So here we will assign a to st dot top, st dot top. So what will be our top? Our top will be 4 since we have pushed it after 5. Then again we will pop it so that 4 goes, and what remains is 5. And again we will do st dot pop so that b will get assigned with 5. And we will perform the operation c equal to b plus a. 5 we are writing b plus a. Since 5 is after 4, in basically it will be like this 5 and 4. So this will get assigned with b and this will get assigned with a. So we have to perform operations like 5 plus 4, 5 minus 4, 5 by 4. So therefore we are writing b plus. Then we are pushing st dot push into our stack. So that here we get operation here, then 5 plus 4. So 5 plus 4 we will get 9. So we will push 9 in back into our stack. Since it is popped out, our updated stack will become 9. So we will perform this until only the final elements. So if we encounter minus, so it will come here, and again similarly it will do int c equal to b minus a. If we multiplication, it will do int c equal to b into a. If we encounter s of division, then it will do b by a. And this is power. Here we use power function present in C++ due to the power a. And finally we output st.pop, which is our only element remaining in the stack. So we will run this code. So here I will input, as we took the example for expression, 5, 4 and plus. See, it gave us output 9. So a stack a stack data structure is working perfectly fine, and our postfix expression evaluation is also working perfectly fine. So this is used by machines to easily carry out postfix expression. It is easy for machine to carry out postfix expression than an infix expression. So this is used by compiler also to evaluate our expressions. So this was the explanation of experiment 2, postfix expression evaluation. That is what is we also call as reverse Polish notation. Thank you.